Hey kids, these are our review questions. So we're going to go through them one by one. If you feel you understand a portion of it, just move forward and you can fast forward through it. So don't feel you need to watch the whole thing. Okay, here we go. Hey everybody, let's start with a little percent composition. We'll do 8A and B, which you might also see in your GIM kit. So A says, calculate the following to four significant figures. The percent composition of ammonia. So I want to know what percent mass is the nitrogen and what percent mass is represented by hydrogen. So I'm going to list them. I have one nitrogen, I have three hydrogens. We're just going to find the molar mass or the atomic mass using our periodic table like we've done many times already. 1 times 14.0, 3 times 1.0 equals 14.0 equals 3.0, and we add them together, and that's our total. Remember, percentage is the portion of the total. So what percentage is nitrogen? Well, it's 14.0. This is AMU, AMU, AMU. Or you could also say grams per mole. The number's the same. They're going to cancel out, so it doesn't matter. Divided by the total of 17.0 AMU. And then I got to multiply it by 100 to get the percentage. Take my trusty calculator. 14 divided by 17 equals times 100. Okay, 14 divided by, let's try that again. 14 divided by 17. Oh boy, slow down, Straussula. 14 divided by 17 equals times 100. Times 100 equals 82.35. How many sig figs? We got 3 sig figs, right? 3 significant figures. It doesn't really matter. So you just put, you'll see it on the test. I'll give you the sig figs, don't worry. 82.4, we'll call it. Percent of it is nitrogen. Since the rest is hydrogen, it must be 100 minus 82, which is 17.6% hydrogen. That's your answer. Okay. Let's do 8B. B says, find the percent composition of photographic fixer solution called hypo, Na2S2O3. We're going to list all of the atoms here. We say 2 times, 3 times. Go to periodic table. Sodium is 23.0. AMU. Sulfur is 32.1 AMU. And oxygen is 16.0 AMU. Have you memorized oxygen yet? We see it all the time. Multiply across, you get 46.0 AMU. You get 64.2 AMU. You get 48.0 AMU. And we're going to add them all together to, carrying a 1 there, 158.2 AMU. And then that's our total. We're going to divide each amount here by 158. So we got for sodium, we have 46.0 divided by 158.2 times 100 equals, let's go to our calculator. .1% is sodium. Sulfur, we have 64.2 divided by the total, 158.2 times 100. 64.2 divided by 158.2 equals times 100. Is 40.6. Ask yourself, does that make sense? Well, it does represent more of the mass, so it should be a bigger percentage. And it is. And finally, our last percentage for oxygen should make these equal to 100 when you add them all together. For oxygen, we have 48.0 divided by 158.2 times 100. 48 divided by 158.2 equals times 100. Got it this time. 30.3% oxygen. Let's check our work. Add it all up. We got 70.9 plus 29.1 equals 100%. Okay, so that's our answer. 1, 2, 3. Easy peasy. Okay, kids, we're going to do 12A and B, which are just like 13A and B, which were your homework. I think I gave you 13A. Honors, you got B. So there's 4 steps to solving these. On these, they give you percentages, but we need to convert to moles. Assume you have 100%. So let's look at the steps. So it says determine the empirical formula. You have 15.8% carbon and 84.2% sulfur. Assume you have 100 grams. Therefore, you would just convert the percentage to grams, which I did here. I said 15.8 grams of carbon, 84.2 grams of sulfur. Convert grams to moles using the periodic table. I know that there's 12 grams per mole of carbon. I'm going to put grams on the bottom because I want them to cancel out. And I get 1.32 moles of carbon. Then I have 84.2 grams of sulfur. I go to my periodic table. I know that sulfur is 32.1 grams per mole. I put grams on the bottom, cancel them out, and I get 2.62 moles of sulfur. The next step is to find the ratio by dividing the smallest amount of moles into the other amounts. Well, we have 2 amounts, so I'm going to divide. We have 1.32. I'm going to divide that into 1.32. I have 1 carbon for every, this is a ratio, there's 2.62 divided by 1.32, and that comes out to 2 sulfurs. So for every 1 carbon, I have 2 sulfurs. That's a 1:2 ratio, CS2. Now we're going to look at 12B, which is 40% carbon, 6.7% hydrogen, and 53.3% oxygen. I just converted those all to grams. I go to the periodic table. I know that there's 12.0 grams of carbon for every 1 mole of carbon. I know that there's 1.0 grams of hydrogen for every 1 mole of hydrogen. It's getting a little crowded. I know that there's 16.0 grams of oxygen for every 1 mole of oxygen equals. So I'm going to 40 divided by 12. My calculator here. 3.33 grams of carbon. Here I have 6.7 divided by 1. That's easy. 6.7 grams of hydrogen. Did I say grams? What should I say? I converted to moles. Grams cancel out and I'm left with moles. So 3.3 moles of carbon, 6.7 moles of hydrogen, and 53.3 divided by 16 equals 3.33 moles of oxygen. Can you see the ratios already? I know that 3.33 is about half of 6.7. So just if I divide everything by 3.33, the slash means divide, right? Equals, equals, equals. There's 1 mole of carbon for every 2 moles of hydrogen and every 1 mole of oxygen. So my empirical formula is CH2O. Number 20 says, what information is needed to calculate the molarity of a sulfuric acid solution? Well, molarity is moles per liter. So if I was given grams of sulfuric acid, I would need to know how many grams I have. Or if I'm given moles, I need to know how many moles of H2SO4. One or the other. You need to know one or the other. And then you need to know the volume. You might see the volume as milliliters or liters. You need to have one or the other. If you have this, you need to convert. If you have this, you need to convert. If you have grams, you need to convert to moles. If you have milliliters, you need to convert to liters, and then plug both in to this formula here. That's 20. Hey everybody, let's do some practice problems. We're in Unit 6. Let's do 22A. It's just like 23A in your homework, only different because I'm not going to do your homework for you. It gives me 0.444 moles of COCl2 in 0.654 liters. My first thing I want to do is circle the givens and underline the unknowns, which is easy for these because here's the givens and here's the unknown. I'm going to identify what's the formula. I know that molarity, big M, which is this, big M, molarity, equals moles per liter. The second step, or the third step, is to convert if necessary. Do I need to convert? Well, let's see. Do I know moles? I do know moles. Do I know liters? I do know liters. I don't need to convert. All I need to do is isolate the unknown variable, but it's already isolated. It's already by itself as molarity. So I don't need to do any isolation, and I don't need to do any conversions. I just need to plug in and solve. Easy peasy. I'm going to get in the habit of writing the substance in there, and I'm going to plug in 0.654 liters. Now I've got my trusty calculator. I say 0.444 divided by 0.654 equals, well, that's a lot of numbers, 6, 7, 8, 8. Now there's 3 significant figures in my given, 3 significant figures in this given, so I need to give 3 significant figures in this answer. So I go to 1, 2, 3, the 4th significant figure, which is the 8, and it rounds up. So since 8 rounds up, the one before it becomes a 9. And the unit is molarity. So let's do 22B, which is just like 23B. This time I'm given grams and solution, and it asks, what is the molarity? Well, I know that molarity equals moles per liter. Do my units match? Moles, grams, liters, liters. I do not match. So I need to ask myself, do I need to convert? I do. So how do I get to moles from grams? Well, I say 98.0 grams of H3PO4 multiplied by a fraction. How many grams are in 1 mole of H3PO4? Well, that's going to take some molar mass, so I go to my trusty periodic table. So my periodic table gives me the molar mass. I have 3 hydrogens times 1 gram per mole, 1 phosphorus times 31 grams per mole, and 4 oxygens times 16 grams per mole. I add them all together and I get 98 grams per mole. Oh, I see where this is going. For every 1 mole, there's 98.0 grams. Those cancel out. I have 1 mole. Divided by how many liters? 1 liter. What? So grams cancels out. Grams cancels out. I have 1 mole over 1 liter is 1.00 molar H3PO4. And that's my answer. Just to show you, the 98s cancel out too, right? 98 on the top, 98 on the top. And then everything winds up 1, divide by 1, get 1. All right. Here's 22C, everybody. It asks for the molarity, just like the other two. This is just like 23C in your homework. Only different numbers and different compound. And so it gives us 0.2074 grams of calcium hydroxide, CaOH2. Remember, this 2 distributes. That's 2 hydroxide ions, 2 O's and 2 H's, in 40.00 milliliters of solution. So I know those are my givens. What's my unknown? Molarity. I know molarity is moles per liter. Do I have moles? No. I need to convert to grams. Do I have liters? No, I have milliliters. Let's see this. So I need to convert milliliters to liters. Well, I do a little calculation over here. I have, in calcium hydroxide, I have 1 calcium, 2 oxygens, 2 hydrogens, comes out to 74.1 grams per mole. So if you just look at this, I'm gonna convert grams to moles. Moles on the top, grams on the bottom. And the grams cancel out, and I'm left with moles. On the bottom, I'm going to convert liters, milliliters to liters. So I have 40 milliliters. I have one liter over 1,000 milliliters. Milliliters cancels out. So I'm going to multiply these. I'm going to calculate these across. 0.2074 divided by 74.1 is 0.00279 moles. Then I got 4.00 divided by 1,000 is 0.04000 liters. I'm doing sig figs. That's why I have 4 significant figures, because they gave me four significant figures here and 4 here, so I'm carrying out 4. And then I divide, and my answer is 0.06998 molar solution of calcium hydroxide. Okay? Remember, after you do the even problems, you can always check your answer by clicking on the number that's in blue. So 22C was indeed 0.6998 molar solution. Next is 26A and B, which says calculate the number of moles and the mass of the solute in each of the following solutions. When you're solving these problems, be sure to go through Mr. Strauss's not-so-patented steps to solving word problems. And here are the steps. First, we identify the givens and the unknowns. It gave us 2 liters of H2SO4. It said it was an 18.5 molar solution. Guys, this is just like the other one, except we're going to find grams at the end. So we need to know the formula. The formula is the only one we have so far, which is this. Molarity equals moles over liters. But we want moles by itself. We want to isolate the unknown variable. The unknown is moles. So we want to get moles by itself. So we multiply both sides by liters. That will cancel out on this side, and I get moles equals liters times molarity. Now I'm gonna see if I need to convert. I have liters and I have molarity. There's no conversions needed, so I'm gonna plug in. Liters is 2.00 liters, and then this is 18.5 moles per liter, because molarity is the same as moles per liter, right? Why am I doing this? Because the next step says 2 cancel out units. So I want to write it like that so I can cancel out units. And sure enough, I cancel liters on the bottom, liters on the top, and I'm left with moles. Then I multiply. 18.5 times 2 is 37.0 moles of H2SO4. That's the first question. The next question says, well, how many grams are there? Well, now, if I want to do that, I have to find the molar mass of H2SO4, which I did here. 2 hydrogens, 1 sulfur, 4 oxygens. 2 times 1 is 2. 1 times 32.1 is 32.1. 4 times 16 is 64.0. I add them all together. I get 98.1 grams per mole. That's the molar mass of H2SO4. Then I have my first answer here. I multiply that by 98.1 grams per mole. I have grams on the top this time because I want moles to cancel out. And I get 3,630 grams. I write that in scientific notation as 3.63 times 10 to the third grams. That one's kind of a jumbled mess, so let's do 26B together. Again, that was 26A. (26B) is the same kind of problem, except they gave me milliliters, but they did give me molar. So I'm going to write down the givens, and my unknown is both two problems here, moles and mass. So first I'll find the moles. Once I find the moles, it's easy to find the mass. I go to my trusty periodic table and convert. So let's do it. Okay, we're given 100 milliliters of 3.8 times 10 to the negative 6 molar sodium cyanide. The minimum amount for lethal injection, it says. Ooh, cyanide is a lethal anion. And we want to find the number of moles and also the grams in this solution. So we have identified the givens and the unknowns. What's our formula? The same as it's ever been. Molarity equals moles over liter. Convert if necessary. Do I have moles? No, I have to find moles. So let's isolate the unknown variable. Multiply both sides by liters, and I get moles equals liters times molarity. Now, do I need to convert? Well, I have liters. No, I have milliliters. Do I have molar? Yes. But do I have liters? No, I have to convert. So 100 milliliters. I know that there's 1,000 milliliters for every 1 liter. So that's going to be 0.1. Cross out the zeros. Make it easy for yourself. 1 divided by 10 is 0.1 milliliters. Let me just check that question to see how many sig figs I need. It says, 100.0 milliliters. Whoa, that makes a difference. So if I'm given 100.0 milliliters, that's 4 significant figures. I need to do 1, 2, 3, 4 liters. So it's 0.1000 liters, 4 significant figures, 2 significant figures here. We'll give our answer in 2. We'll give our answer in the least amount of significant figures given, which is 2. So really not necessary to carry these out. So plug them in. We've converted. Plug it in. We have 0.1000 liters times 3.8 times 10 to the negative 6 molar solution. Let's put that in our calculator. I'm going to use the phone this time, because I think a lot of you are using your phone. Remember, now we have scientific notation, so we need to turn our phone sideways and use the scientific calculator. We have 0.1. I don't have to put those zeros. They're just placeholder. I mean, they have value, but I don't need to put them in the calculator. Multiply by 3.8 times 10 to the negative 6. How do we do that? The EE button right here, times 10 to the negative 6. Remember, the EE button means times 10 to the. So just put EE negative 6. And what do I get? I get 3.8 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. 10 to the negative 7. That makes sense, because I just had to, when I multiply by 0.1, I just have to move the decimal over 1. So that's negative 7, and that's molar solution of sodium cyanide. That's the first part. The second part wants grams. So I need to write out 3.8 times 10 to the negative 7. Sorry, did I say molar? That's not molar. What is it? What do we solve for? We solve for moles. There's that many moles of sodium cyanide. Now, if we have that many moles of NaCN, we need to know the molar mass. So with some calculations, we have 1 Na, 1 C, 1 N. We have Na is 23.0 grams per mole, 12.0 grams per mole, 14.0 grams per mole. Okay. Add them all together, you get 49.0 grams per mole. So I'm going to convert this. For every 1 mole, there's 49.0 grams of NaCN. NaCN. The moles cancel out, and I'm left with grams. Let's put that in our calculator. 49. Oh, here we have 3.8 here, so let's multiply that by 49. And we get our answer, which is 1.8 times 10 to the negative 1, 2, 3, 4, 5. 10 to the negative 5 grams of NaCN. All right, so here's our two answers. Let's see if we got them right. Well, when I look at the answers, I see the first answer is correct. I got 38.107, but my other answer is 1.9 times 10 to the negative 5. What mistake did I make? Let's look. On my calculator, I wanted two significant figures, but I need to go to the third one. That's 6 rounds up, so it becomes 19. So our answer is 1.9 times 10 to the negative 5th is the right answer. Good job, everybody. Okay, now we're going to do 32 and 34, which say there is about 1 gram of calcium as calcium plus 2 in 1 liter of milk. What is the molarity of calcium plus 2 in milk? Well, let's check it out. I've identified my given and my unknown. 1 gram of calcium, 1 liter of solution. Molarity, what's my formula? Molarity equals moles over liters. Do I need to convert? Well, I have grams, not moles, so I do need to convert. So I say there's 1 gram of calcium times for every 1 mole of calcium. Go to my periodic table, find the mass of calcium. Don't get thrown off by that plus 2. That means it lost electrons, but electrons' mass are negligible, so the mass stays the same, 40.1 grams. And I divide 1 divided by 40, and I get 0.025 moles of calcium. Plug that into my formula. It's 1 liter, so that's easy. 0.025 moles divided by 1 liter equals 0.025 molar solution. Calcium, okay? Calcium solution. Easy. We have a new type of problem with 34. We have liters, molar. We have a new molarity. What's the new liter? So this is one of those dilution problems, okay? So what's the given? Let's write down the given and find the unknown. We have, well, let's write down what's given and we'll figure out what the formula is. Okay, 34 says this right here. We start with this amount of liters of this molarity, and then we go to this molarity. Now, that doesn't give us grams, it gives us moles, so I don't really need to even deal with the substance this time. I'm just going to ignore the substance. If they gave us grams, then we would need, or if they asked for grams at the end, we would need to know the substance. But on this one, we don't need to know the substance, so let's look at that. Okay, here's before, we call it 1. Here's after, we call it 2. We started with this many liters, this molar solution, and then we finished with this molar solution. We want to know how many liters did we dilute it to? So what's our formula? M1L1 equals M2L2, multiplying, right? So, but what do we need? We need L2. So we're going to circle that. We need to know, we know we need to get that alone. So we're going to divide M2 on both sides. Cross out M2 here. We get L2 equals M1, L1 divided by M2. Do we need to convert? No, we don't. So we just plug in right here, go to our calculator. We put 0.3556, there it is, times 0.1718 equals, now I'm divide by the bottom, divide by 0.1222 equals, ooh, we need 3 sig figs, right? Because we got, actually we need 4 significant figures. We got 4 significant figures here, 4 here, and 4 here. So we need to go to the 5th significant figure, which if you can see it is 3. And, okay, well, it's a little strange. You know what? Let's just make our lives easier and call it 0.5000. All right. And we're done. And what are the units? Liters. The next thing it asks us to review is the PhET simulation. I've already made a video of that in 6.07 on this assignment. I made a 15-minute video right here, 14 minutes, so you can review the PhET simulation, but it's very similar to what we're already doing. It's actually easier. So you may need to review that, you may not. And what's finally, we need parts per million, parts per billion. Let's look at that. For this assignment, we were supposed to do 4, 5, 10, and 11. Let's do those. Number 4 says, what is the concentration in parts per million of selenium if 1.3 milligrams is found in 250 or 2,500 kilograms of soil? So we have a very small amount of grams here. Milligrams is 1/1000th of a gram. And then we have a very large amount of soil. Kilograms is 1,000 times or 1,000 grams each. We don't need to know that it's selenium. We don't need to do any conversions. It already gives us grams. So if it gave us moles, we'd need to know the substance. But for this one, we deal with grams. Okay, as long as you have grams on the top, grams on the bottom, multiplied by 1,000,000, it should be easy. Let's check it out. Okay, I've written out the givens. We have 1.31 milligrams of selenium and 2,500 kilograms of soil. In this case, selenium is our solute and soil is our solution. So we need to convert them both to the same unit. All right, so it might be just probably easier to just convert them both to grams. Why don't we just do it on the top here? We know that there's 1,000 milligrams for every 1 gram. We'll convert that one, move this over 3. 1, 2, 3. 0.0013 grams of selenium. Let's convert this one. We know that there's 1 kilogram for every 1,000 grams. I want kilograms to cancel out, just like milligrams canceled out up here. And I multiply 2,500 times 1,000, so that's 2,500. Add another 3 zeros. And I'm going to divide these. This is soil, grams of soil. I'm going to divide these. Use the phone because it's much more clear on our camera here. So 0.0013 divided by 25. How many zeros is that? 5 zeros. 1, 2, 3, 4, 5 equals 5.2. That's EE right there. So that means times 10 to the negative 10. But we're not done because we have to multiply. So this is the fraction, but we need to multiply the fraction by 10 to the 6th because the question asked us for parts per million. Now, when we do that, we have a negative exponent times a positive exponent. We add them together. Negative 10 plus 6 is negative 4. So our answer is 5.2 times 10 to the negative 4 ppm. We can check our work right here. And sure enough, it's 5.2, 1, 2, 3, 4 to the negative 4th ppm. Yay, we got it right. On number 5, we have the highly toxic PCBs in soil. This is a chemical that comes off of cars and accumulates in soil, especially next to freeways. So let's look at that. I've put this one on top of this one. I need to convert them both to grams, just like we did before. We have 1 gram for 1,000 milligrams. We have 1,000 grams for every 1 kilogram. So we're going to multiply across. Or sorry, we're going to divide this one. Move the 1, 2, 3, 0.00. I'm going to fill in zeros here. The decimal goes here. So 3 0, 4 zeros. 60 grams of PCBs for every, I have to add 3 zeros to what we have, 46,4600, 1, 2, 3. Now I'm going to multiply this whole thing by 10 to the 9th. That's parts per billion. So let's do this math. We have 1.3 times 10 to the negative 11. I'm going to multiply it by billion, and that's going to, negative 11 plus 9 is negative 2. So we get 10 to the negative 2. 1.3 times 10 to the negative 2 is our answer. ppb. Lowercase b. All right. That's your answer. Let's check it. We have 1, 2. 1.3 times 10 to the negative 2. That's what we got. Yay! We did it right. Okay, here's number 10. Now, 10's a tricky one because it gives the solvent in milliliters. So let's take a look at that one. So here are our givens. We have 250 milliliters of H2O and 0.808 grams of calcium chloride. Here's our solute. And here's our solvent. Now, normally we don't want to use solvent. We want to use solution because when you add them together, they make the solution. But when you're doing ppm and ppb, our solvent is so small that it's negligible and is not going to change the volume of solution. So we can actually do these with just the volume of solvent, not the volume of solution. It's not going to change the volume. So what's our formula? We know we need to divide, and then we need to divide grams by grams and multiply by, well, what's it asking for? I forgot. I didn't look. It's asking for ppm. So we need to multiply by 10 to the 6th. Well, how do you go from milliliters to grams? Well, you might remember from the beginning of the year that 1 milliliter equals 1 gram when you're dealing with water. If you remember that only water is 1 gram per milliliter. That's how they came up with the milliliter. It's fascinating. So, or is that how they came up with the gram? I don't know. But the point is, 1 milliliter of water equals 1 gram of water. That's only true for water. So that means we have 0.808 grams of solute over 250 milliliters of solvent. But we can just switch this milliliters to grams. Easy. And then multiply by 10 to the 6th. Because it's asking for parts per million. Take our trusty calculator. 0.808 divided by 250 equals times 1, 2, 3, 1, 2, 3. 3232. Parts per million. You can also write this in scientific notation. 3.232 times 10 to the 123 parts per million. Okay, you don't have to write it in scientific notation, but you should know your scientific notation. And let's do number 11. Number 11 is pretty much the same question, except it's asking for the chloride ion. Strictly the chloride ion. So let's take a look at that. We're going to say 63.9% times 3.232 EE3 equals 2.065 times 10 to the 3rd power. 1, 2, 3 ppm. That's our answer. Let's check it. Close enough. All right. Why is it all 3 sig figs? Let's look at the question. As long as we're looking at sig figs. The question gave us what? Nope, you have 3 significant figures. Okay. So let's fix our paper for that. So 1, 2, 3, the 4th one rounds up, and we get 6.07 times 10 to the 3rd. All right, excellent. Another way to look at it, and maybe an easier way to look at it, is to say we have a 0.808 grams of calcium chloride for every 250 grams of H2O. And then we have 71.0 grams of chloride ions for every 111.1 grams of CaCl2, which we got from here, 71 over 111. And that should give you the same number. All right, so you could do it either way. Yeah, notice you cancel out the grams here, and you're left with grams of chloride over grams of water, which is what you want. Thanks, everybody.